Now we will discuss about allotropes of phosphorus. The three main allotropes of phosphorus are white phosphorus, red phosphorus and black phosphorus. Out of these three allotropes, white phosphorus is a chemiluminescent substance. Due to the chemical reaction with air, it glows in the dark. That's why white phosphorus is used in light emitting diodes. Keep in mind, white phosphorus is a reactive substance. It catches fire in the presence of air. That's why it plays a significant role in combustion reaction of matchbox. Another important use of allotropes of phosphorus is in the matchbox. Matchstick head contains sulfur and potassium chloride. Potassium chloride is a strong oxidizing agent which supports combustion reaction. The friction surface of the matchbox contains red phosphorus and glass powder. The glass powder makes the friction surface more rough. When matchstick head is rubbed against a rough surface, friction causes heat. The heat converts red phosphorus into white phosphorus, which catches fire in the presence of air. Potassium chloride supplies oxygen to support combustion reaction. Sulfur combines with oxygen to form sulfur dioxide to produce a long-standing flame. The bad smell released during the combustion reaction is due to the formation of sulfur dioxide gas. This reaction is so fast that it completes in 1/10 of a second. These are some important points about allotropes of phosphorus. Now let's discuss about these allotropes one by one. First, we will discuss about white phosphorus. The chemical formula of white phosphorus is P4. White phosphorus can be prepared by heating phosphate rock. About the occurrence of phosphorus, we have learned already. Phosphorus is obtained mainly from the apatite family. For example, we have fluoroapatite. It is an example of phosphate rock. When phosphate rock is heated in the presence of carbon and silica, we get vapors of phosphorus. And on cooling these vapors of phosphorus, we get white phosphorus. Okay, this is industrial method. Industrially, that is how we prepare white phosphorus. Let me write this preparation reaction. There is only one preparation reaction we have. Okay, we have phosphate rock. On heating in the presence of carbon and silica, we get vapors of phosphorus. Vapors of phosphorus. And on cooling, you can write on cooling these vapors, we get white phosphorus. White phosphorus. White phosphorus, that is P4. Okay, we get white phosphorus. This is the only one method we have for the preparation of white phosphorus. There are some selective physical properties we have. I have already written. Keep in mind, white phosphorus is poisonous substance. It is a wax-like solid, can be compressed. Does not dissolve in water because water is polar by nature, and so phosphorus P4, same type of atoms are there, and it is almost non-polar by nature. Non-polar and polar does not dissolve. Okay, it dissolves easily in non-polar solvents such as we have carbon disulfide. It is non-polar. Okay, dipole moment in this case is 0. Okay, now we move on to next property. Important property you have, white phosphorus glows in the dark. Okay, this is the important property we have regarding white phosphorus. Any chemical which glows in the dark. Okay, this kind of phenomena is known as chemiluminescence. This kind of phenomena is known as chemiluminescence. Now we talk about its structure. There are 4 phosphorus atoms. Okay, they are arranged tetrahedrally. Each phosphorus is forming how many bond? 3 bond. Since each phosphorus is forming 3 bond only, that's why each phosphorus will carry 1 lone pair. Now pay attention carefully. You can see this is the bond angle we have, that is 60 degree. A small bond angle is there, that's why there is a angular strain. There is a angular strain is there. Another important point, there is a angular strain. Okay, this is the first point. Second point, you can see these atoms are closer, that's why you can see this is the lone pair electron density, this is the bond pair electron density. There is a bond pair and lone pair repulsion is also present. Okay, bond pair repulsion is also there. Bond pair, lone pair repulsion is also there. Due to these 2 factors, this structure is quite unstable. Okay, due to these 2 factors, this structure becomes unstable, means highly reactive. Okay, it becomes unstable, hence means it becomes highly reactive. Means this structure is not stable due to angular strain as well as bond pair, lone pair repulsion. This is the reason in air it catches fires. Okay, now let's move on to its chemical properties. Next we have chemical reaction. First chemical reaction is with air. Okay, with air. It catches fire in air and easily gets oxidized to produce phosphorus pentoxide. Okay, we have white phosphorus, that is P4. In the presence of oxygen in air, undergoes oxidation to produce phosphorus pentoxide. Okay, it can also be written 2P2O5. It undergoes dimerization to be in a stable state because it has number of electron. Okay, P4O10, this is phosphorus pentoxide. Okay, you can balance multiplied by 5. It is in gaseous state and it is a white solid substance. White phosphorus, it is in the solid state. We get a dense fume. Okay, dense fume will start coming out once it comes in contact with air. Okay, now next chemical reaction we have, it also react with strong alkali such as we have sodium hydroxide. Okay, strong alkali. We have white phosphorus reacting with sodium hydroxide in aqueous medium. Let's say water is also present. It produces phosphine and another substance will come as NaH2 and it is PO2. It is known as sodium hypophosphite. Sodium hypophosphite. You can balance this equation. You can take 3 molecules, 3 sodium multiplied by 3. Okay, how many phosphorus? 3 phosphorus plus 1 phosphorus is equal to 4 phosphorus. These are some selective chemical reactions of white phosphorus. Now let's move on to red phosphorus. Next we have red phosphorus. The chemical formula of red phosphorus is same as does white phosphorus have, but the arrangement of atoms is different. That is how they show different physical as well as chemical property. Red phosphorus can be prepared by heating white phosphorus at the temperature of 250 degrees Celsius in the presence of a catalyst, that is iodine. Very simple preparation reaction we have. We have white phosphorus. When heated at 250 degrees Celsius in the presence of iodine as a catalyst, we get red phosphorus. It means white phosphorus can be converted into red phosphorus at the temperature of 250 degrees Celsius in the presence of a catalyst iodine. Okay, this is the only one preparation method we have. Now let's move on to its physical properties. Red phosphorus is odorless. It is non-poisonous substance unlike white phosphorus. White phosphorus is poisonous by nature. Red phosphorus is insoluble in both water as well as carbon disulfide, polar as well as non-polar. Almost it is a rock. Okay, it does not glow in the dark. Since it does not glow in the dark, that's why it does not show the phenomena of chemiluminescence. Okay, white phosphorus shows the phenomena of chemiluminescence. Now next we have, it is less reactive than white phosphorus. Since it is less reactive than white phosphorus, that's why it does not ignite in air. It does not catch fire in air like white phosphorus. Now we talk about the structure. See, it has polymeric structure. It has polymeric structure. Okay, polymeric structure is there. One tetrahedral unit is connected with another tetrahedral unit and a long chain is formed. For example, we have phosphorus. Okay, then we have phosphorus is there, and so they are connected via phosphorus linkage. Phosphorus is there, phosphorus, then and so on. Okay, that is how this structure will keep on moving. Okay, so you can see each phosphorus is forming how many bonds? 3 bonds, and each phosphorus is having one lone pair. Okay, that is how the structure is. Okay, so it's kind of a lattice. That's why it is less reactive than white phosphorus. Now let's move on to black phosphorus. Next we have black phosphorus. Black phosphorus is present in 2 different forms. One is alpha black phosphorus and other is beta black phosphorus. One by one we discuss. First we discuss about alpha black phosphorus. Keep in mind, alpha black phosphorus can be obtained or can be prepared by heating red phosphorus at the temperature of 803 Kelvin. Okay, we have red phosphorus. When it is heated in a sealed tube in a closed container at the temperature of 803 Kelvin, then we get alpha black phosphorus. Okay, alpha black phosphorus. Now let's move on to its physical properties. Alpha black phosphorus, we have alpha black phosphorus easily sublimes in airs, okay, undergoes sublimation, like we have camphor, naphthalene balls are there. It exists in opaque monoclinic as well as rhombohedral structure. This kind of structure we have studied in solid state. Now next property, it does not burn in air like we have white phosphorus, means it does not undergo oxidation in air, okay, means it is less reactive. Simple thing, it is less reactive. Now let's move on to beta black phosphorus. Next we have beta black phosphorus. Beta black phosphorus can be prepared by heating white phosphorus at the temperature of 473 Kelvin under high pressure. Let me write this preparation reaction. We have white phosphorus is converted into beta black phosphorus at the temperature of 473 Kelvin under high pressure. We get beta black phosphorus. Beta black phosphorus. Keep in mind, beta black phosphorus does not react with air up to the temperature of 673 Kelvin. Okay, I can write no reaction with air up to 673 Kelvin. When we increase the temperature above 673 Kelvin, then reaction will start taking place, means at that time, at that high temperature, it will undergo oxidation, okay, reacts with air above 673 Kelvin. Okay, keep in mind, beta black phosphorus is the most stable allotrope of phosphorus. When we talk about the stability among the main allotropes of phosphorus, black phosphorus is more stable than red phosphorus, and red phosphorus is more stable than white phosphorus. Okay, we talk about stability orders. We have black phosphorus more stable than red phosphorus, more stable than white phosphorus. Means white phosphorus is highly reactive among the allotropes of phosphorus.